Graad 10 voordat ons aangaan met die werk waarmee ons nou besig is, wil ek eers vinnig terugspring na bladsy 137 toe. And we're going to talk about chemical bonds. Because to understand intermolecular forces, which we have to do now, we first have to look at intramolecular forces. So wat gebeur is, chemiese verbindings vorm tussen elemente om verbindings te vorm. So when a reaction occurs, elements react with one another and then forms compounds. But those compounds look differently depending on which type of elements it is. And that's what we are going to explore in this unit. Okay, maar kom ons begin eers by die basics. Ons kyk na die kragte binne in 'n molekule en ons noem dit intramolekulêre kragte. So if you're talking about intramolecular forces, you are looking within the molecule, the forces that are between the elements in that molecule. Okay, en slegs die valensie elektrone neem deel aan hierdie reaksie. For those of you who can't remember from term 1, the valence electrons refers to the electrons in only the outer energy level. Alles van hierdie is op bladsy 137 in julle boeke. So the definition of a chemical bond is a mutual attraction between two atoms resulting from attraction between the nuclei and the outer electrons. So kom ons stop gou eers daar. Onthou die nucleus van 'n atoom is positief gelaai en die elektrone buite om hom is negatief gelaai. So die nucleus van een atoom en die nucleus van 'n ander atoom gaan eintlik mekaar afstoot. But as soon as this attraction power between the nuclei and the electrons of the other atom overcome the repulsion between the nuclei of the one atom and the nuclei of the other atom, then a chemical bond can form. En wat baie belangrik is, graad 10, is julle moet verstaan dat die energie van die gekombineerde atome is kleiner as wanneer hulle nie gekombineer was nie. In other words, it goes to a higher state of stability. And remember, the higher state of stability is when the electrons or the outer level is completely filled with electrons, like with the noble gases. Ons het dit gedoen toe ons die afboudiagramme gedoen het. Toe ons gesê dit is hoekom suurstof byvoorbeeld na O2- toe gaan, want soos wat hy is, het hy nog 2 elektrone wat hy kort in sy buitenste energievlak. But then if you add those 2 electrons, becomes -2 charged, but then it is in a stable state, like a noble gas, because the outer energy level is filled. Okay, dan gaan ons vinnig praat oor Lewis diagramme. And you guys are going to do a lot more of these in grade 11, but we just need to understand the basics of it. So for a Lewis diagram, we only look at the valence electrons, want onthou dis net die valensie elektrone wat gaan deelneem aan die verbinding. So let's say we are looking at these molecules. Onthou, as ons kyk byvoorbeeld na lithium, weet ons hy het 3 elektrone, maar net een van hulle is 'n valens elektron. So then if you want to represent lithium, you're going to make Li and a dot. Jy mag die kolletjie hier langsom ook maak, dit maak nie saakie, as long as you represent that it has 1 electron in its outer energy level. Dan as ons kyk na beryllium, remember beryllium has 4 total electrons, but 2 of them are in the inner energy level, so only 2 of them are in the outer energy level. En nou moet julle mooi onthou van laas kwartaal af, ons vul mos eers die s-orbitaal, and for the s-orbital they pair up, so then it looks like that. Maar as ons aangaan na, ek gaan nou skiep oor 2, kom ons kyk byvoorbeeld na stikstof. So nitrogen has 7 electrons, 2 of them are in the innermost energy level, so only 5 of them are valence electrons. So dan maak ons N in die middel, en ons maak 1, 2, they paired up, and then they go 3, 4, 5. Nie opgepaar nie. Die honde is nou eers besig om mekaar hier so te stoei. Gaan lê. Sorry guys. Okay, so dan lyk hy so. Die rede hoekom ek oor die ander 2 geskiep het, is omdat koolstofsin lyk bietjie anders. Carbon, you need to know, he has 4 electrons, but instead of going 1, 2, 3, 4, you place them equally around the carbon atom. So gaan maak maar net seker van koolstofsin. If we go further and we look at oxygen, oxygen has 3, 4, 5, 6 valence electrons. Onthou hy het 8 elektrone, maar net 6 van hulle is valensie elektrone. So then let's pair them up. We go 1, 2, 3, 4, 5 en onthou julle dan daai wat sê daar moet eers een elektron wees in elke orbitaal en elke p orbitaal voordat ons hulle begin oppaar. So it's 1, 2, 3, 4, 5, 6. So hy lyk so. So sien julle hierso is plek vir nog 'n elektron en hierso is plek vir nog 'n elektron. But if I add those two electrons, this is no longer oxygen. It is oxygen 2 minus. Ons gaan nou nog maar gaan kyk daarna. Kom ek vee net daai twee kruisies uit. And then if we look at fluorine, it has 7 electrons. So it's F in the middle, 1, 2. S orbitaal gevul. Nou kan ek begin met die p orbitale. 3, 4, 5, 6, 7. So do you see there's space for one more electron there? Then it is at a noble gas state. En dis hoekom fluor gaan na fluor 1 minus toe om daai orbitaal vol te maak. And then the last one I want to look at is neon. Now neon is one of the noble gases, meaning that its outer energy level is completely filled. So as ek hom gaan teken, gaan ek 1, 2, S orbitaal is gevul, 3, 4, 5, 6, 7, 8. So soos julle kan sien, is daar nêrens plek vir nog elektrone om in te kom nie. Met ander woorde, hy is klaar in sy mees stabiele vorm, so hy gaan nie reageer nie. Okay, all of those are drawn on page 138 as well. But now we're going to look at, once we have these electrons in the outer energy level, what are they going to do? Want onthou, soos wat hulle nou hier is hulle nog allemaal elemente, hulle het nog nie gereageer nie. Okay, so as ons bijvoorbeeld gaan kyk na chloor, chlorine, as you guys can see, he's over there. In other words, he has 7 valence electrons. So hy gaan wees 1, 2, 3, 4, 5, 6, 7. And we know that chlorine likes to be diatomic. Dit is vir hom 'n meer stabiele vorm. So wat gaan gebeur is, daar gaan nog 'n chloor wees. 1, 2, kom ek maak syne met kruisies. 1, 2, 3, 4, 5, 6, 7. And then what's going to happen is this electron here and this electron here is going to overlap, and they are going to share those electrons, meaning that I must push these two together. So dan lyk hy so. Okay, so now if I go and look, this chlorine has 8 electrons around it, en onthou hy soek 8 elektrone, want dan lyk hy mos soos neon. So hy het sy 8 elektrone rondom hom, en as ons verder gaan, hierdie chloor het ook sy 8 elektrone rondom hom. Met ander woorde, hy is ook happy. Okay, but I want you guys to practice a few of those. I'm going to upload the memo for you. Ek wil hê julle moet by oefening 8 nommer 1, and I don't want you to do all of them. I want you to do argon, potassium, hydrogen, chlorine, then I want you to also do magnesium, and I want you to do aluminium. Okay, ons het hulle afboudiagramme al geteken. Gaan kyk net vir my na die Lewis strukture. So you start off by first identifying how many valence electrons, and then you fill the orbitals. So onthou dis eers die 2 in die p orbitaal. Ag ek jok, in die s orbitaal. And then you carry on, and then you fill the other 6 in the p orbitals.